Hello everybody. Now that we've talked about some of the common vocabulary that we'll discuss in statistics, let's talk about some of the basic ways that we can organize our data, two of which are frequency distributions and histograms. All right, so let's say we were going to survey our class and we found that 25 students had brown hair, 5 had blonde hair, 12 had black hair, and 3 had red hair. How could we organize this data? Well, in statistics, we would call the hair color, we would consider that what we call a class, and the number would be the frequency, the amount of times that class came up in our survey. We could create a very quick frequency distribution. So, for example, I could have classes and frequency. And my first class is brown hair. And we had 25. Then I had blonde hair, of which we had 5. Then I had black hair, of which we had 12, and red, which we had 3. In its most basic form, this is a frequency distribution. All right, so let's start talking about some of the components of a frequency distribution. And the first is the lower class limit. Now, not all times will your data be qualitative. Sometimes it'll be quantitative. Let's, for example, take the example of ages. Let's say ages in our class. Our first class might be 18 to 21 years old. The lower class limit would be the 18. The upper class limit would be the 21. And then, of course, we can't use 21 twice, so our next class would be 22, let's say, to 25. Any questions thus far? Now, our class width is the difference between the lower class limits. So you could do it one of two ways. You could do the difference between the lower classes, so our class width, in this case would be 22 minus 18, which equals 4. Or you could count in between the class. So if I counted 18, 19, 20, 21, that would be 4 units. The key is you have to include both the lower and upper class limits. All right, class boundaries are when we don't want to have any space in between our classes. So I have 18 to 21, 22 to, I'm going to make a little more space there. 22 to 25. Well, there is space in between our class limits. We have 1 unit in between 21 and 22, right? So we want to bring those two things together. So we make what we call a class boundary, where we add up our upper class limit and our next lower class limit, divide by 2, right? So we get, instead of 18 to 21, we add on a decimal, so I can say 17.5 to 21.5. And then the next one would be 5 to 25.5. This will avoid any of your frequencies landing on your class boundaries. All right, it will also create no space in between them, so you could make a histogram. All right, so the next is class midpoint. And we've used midpoint before when we were getting our mean. So for the class midpoint, you would do the upper limit plus the lower limit and divide by 2. And we used the class midpoint when we were getting the mean of our data just about a week ago. All right. Next, I want to define relative frequency. Sometimes your frequencies are not going to be small, like just surveying our class. We could survey NJIT about hair color. NJIT has thousands of students, and we're not going to make any sort of a graph with thousands of frequencies. So we use what we call a relative frequency. And the relative frequency equals the number of times the value occurs divided by the total number of observations. So for example, let's say we are surveying 200 people. All right. For the number of courses that a student was taking in this term. Let's say 70 of those people said 3 courses. The frequency would be 70. The relative frequency would wind up being 70 divided by 200, or 0.35. Now the key to relative frequency, like I said, is we bring the number down. The numbers will always be between 0 and 1, and all of the relative frequencies should add up to 1. All right, the last term I'd like to define is cumulative frequency. All right, it's the number of data values less than or equal to a specific value. So it's kind of like a running total. So we take our relative frequencies and we add them up. So for example, if the number of courses the college student was taking was 70 out of 200, our relative frequency would be 0.35. Let's say for X equals 4 classes, our relative frequency was 0.15. The cumulative frequency thus far would be adding up those two terms, and it would be 0.5. So the cumulative frequency in this example, right, would be 0.5, because it would take the relative frequency of 3 classes and add, right? And then when we get to 4 classes, we would simply add the 0.15. We won't talk about that a whole lot, but it could come up here and there. So histograms. Let's talk about what a histogram is, how to do it, and how to make it. All right, so a histogram is a graph that displays data with vertical bars to represent frequencies. The key with a histogram is there's no space in between the bars. So we use our class boundaries on the horizontal axis versus the class limits. All right, so let's talk about how to create a histogram. Again, it's a vertical bar graph. So step 1 is we need to label the horizontal and the vertical axes. The x-axis, the horizontal axis, will be labeled with the class boundaries, and the frequencies will be on the y-axis. All right, we use those frequencies, all right, for the heights of our vertical bars. All right, so here we have a frequency distribution. Notice I have class boundaries, not class limits. And I have frequency 1, 2, 3, 5, 4, 3, 2. So let's take a moment to go over relative frequency. So the total number of frequencies here is how much? Why don't you pause the video and add them up. Okay, so I hope you got 20, because that's what they should add up to. Now for relative frequency, we're going to take 1, right, in our first class. I'm going to say 1 divided by 20. In our second class, it will be 2 divided by 20. In our third class would be 3 divided by 20, so on and so forth. Why don't you pause the video and fill in your relative frequencies. All right, so let's check our work. So now the way I would check my work is I would either add up all the fractions or quickly convert them to decimals. Remember, no matter whether you added them as fractions or decimals, it should always equal 1. All right, so that is the most important thing. All right, now I'd like you to pause the video, and I would like you to create an X and a Y axis. On your X axis, label your class boundaries. On the Y axis, let's use our relative frequencies. We don't want our histogram to be too tall, so let's put our relative frequencies so you can do them by 5/100ths, 5/100ths, 1/10, 15/100ths, so on and so forth. I'll give you a minute. When you're ready, unpause the video. All right, now that your X and Y axes are labeled, you're going to utilize your relative frequencies to draw vertical bars and create that graph. Go ahead, pause the video and do that as well. All right, let's take a look at our histogram. So your drawing should match mine. Notice there's a little space here between 0 and 5.5. I don't put 5.5 right on top of 0. But then all of my class boundaries are equally spaced, so they should look equally spaced. And again, we utilized our relative frequencies in order to get the heights of our various bars. So your bar between 20.5 and 25.5 should be your tallest at 0.25, and so on and so forth. All right, why don't you pause the video, take a look. If you need to make a revision to your histogram, please do it now. All right, so next I have another frequency distribution. Now remember, the class limits are what your frequencies fall into. Right? The class boundaries are made so you don't have any space in between your class limits, because there are an infinite amount of numbers in between 116 and 117. There's a whole lot of fractions, a whole lot of irrational and rational numbers as well. So why don't you pause the video and take some time to create a frequency distribution. Excuse me, create a histogram. All right, so you should have set up your X and Y axis as follows, with the class boundaries on the X axis and your frequencies on the Y axis. Now this time we're not using our relative frequencies. We certainly could if we had wanted to. We're just going to use our frequencies as laid out. So in the first class, we have 5 frequencies. So I'm going to go from here up to 5, across, and down. And in my next class, I have 9. So I'm going to extend up to 9, go across and down. And in the next one, I had 6. So I'm going to extend across and down. In the next one, I had 6, extend across and down. In the next one, I had 0. Now, a lot of people forget about 0, and they kind of meld the classes together. You need to leave that class open to show that there were 0 in that particular class. So in 304 to 351, I had 1. I'm going to go up to 1, across and down, and I had 1 more over here. So this is the way I would make that particular histogram. All right. So one potential difficulty is that an observation lies on a class limit, and that's why you would use the boundary. The boundary is not going to be one of your data values, right? It's made afterwards. So you cannot have a data value lie on a boundary. All right. So by either adding tenths, or if you had tenths in your data, you could go to hundredths. All right. So that takes that out of the equation. All right. So histogram shapes. All right. We said before that a data set could be unimodal. All right. A unimodal histogram is one that goes to a single peak. A bimodal histogram will have two different peaks, but they will both be of the same height. All right. So, or we could have a multimodal histogram, which means that it goes to more than two peaks. All right. So we could have a histogram looking like this, right? We have multiple peaks, right? 124 players listed on the rosters of the San Francisco 49ers and New England Patriots in 2009. All right. What we notice here is that we have three distinct peaks, right? Doesn't mean that there are three modes. It just means that there are three distinct peaks. The one on the right, the heaviest peak over here is for our linemen. The middle peak corresponds to the linebackers, and the one on the left is the wide receivers, quarterbacks, etc. All right, so let's talk about the shapes of our histogram. Our histogram is considered symmetric if the left half and the right half are mirror images. All right. A unimodal histogram would be considered positively skewed if the right or upper tail is stretched out. Negatively skewed if it leans to the left. All right. So that is a short, quick video on frequency distributions and histograms. I hope everybody has a wonderful day, and I will see you on the other side. Thank you.